Hello and welcome to Module 4 of the tutorial Elementary Programming Principles. In our previous module, we discussed the stages of program development. In Module 4, we still continue discussing the remaining stages, and to kick it off is program coding. Program coding is the actual process of converting a design model into its equivalent program. Coding requires the programmer to convert the design specification or a algorithm into actual computer instructions using a particular programming language. For example, the programmer may be required to write the program code either in Pascal, C, or Java, and develop suitable identifiers, variable names, and their data types. However, remember that this stage is still a pencil and paper exercise. The end result of this stage is source program that can be translated into machine-readable form for the computer to execute and solve the target problem. So at this stage of program coding, the programmer just requires to pick the appropriate programming language and start converting the design model created in stage 3 into its equivalent program. Still, this is not the end product. What is just received from this point is a source program. This source program is something that can be translated into machine-readable form or converted into machine-readable form by the use of a translator. So the coding should be done in such a way that it will result to a source program that can be translated into machine-readable form. Rules followed in coding a program. One of the rules is that you should not use similar variables. A variable is actually a location for data in the computer memory. When a variable is declared, the computer sets aside some memory space to store a value in the variable. In this example, we have a programmer required to develop a program that would be used to solve the equation of a straight line given by the expression of y is equals to mx plus c. So in this case, the user has to declare this expression, and it will be declared in form of variables. So as you can see, in this case we have these initials var to represent variable, and this is just telling the program that the user is about to declare some variables. The user or the programmer goes ahead and declare the variables as y, m, x, c, and they are given the data type of integer. As you can see, the variables are not repeated. If this is repeated, it will bring some confusion in memory allocation, and also as the values are being referred to at a later point in the program. So always make sure that you don't use similar variables to avoid confusion in memory allocation, and also to avoid confusion in a reference while your maybe program statements will require to refer to a certain variable, and then you find that you used similar variables, then it will be confused on which variable to pick. Use reserved words. Every programming language has some reserved words that has a defined meaning. So every programming language will have some reserved words that have a defined meaning. These words make it easy for programmers to code, as one just requires to write a specific word and the program will understand what the programmer wants to do. So always make better use of the reserved words. the programming language that you're going to use, make sure that you at least know some of the reserved words, so that you don't use them for the wrong purpose, so that you make better use of them. Keep spelling as normal as possible. Yeah, just like English, we have some grammatical rules, some syntax that have to be followed. So again, in programming, when you make some spelling mistakes, you find that it may cost you, and maybe at some given point the program may not work. This is, for example, with the reserved words. So if you are going to use a reserved word and then maybe you make a spelling mistake, you find that it might not work for you. So always make sure that you keep the spelling as normal as possible. Use comments to explain variables and procedures. This makes the program readable. So in most of the programming languages, they will allow you to use comments, and this will make it easy for a non-specialist or someone who may not be able to program to understand your program, and it also makes it easy for maintenance, so that whoever may come to maintain or collect or maybe try to debug the program may be able to do it at ease, because you'll have comments that will explain every other step in your program statements. Alright, so those are the rules followed in coding programs, so ensure that you follow them, and these will result into a working program within the shortest time possible. The next stage in program development is program testing and debugging. After designing coding, the program has to be tested to verify that it is correct and any errors detected are removed. So you find that chances are that after designing and coding a program, it will have some errors. These errors may cause the program to malfunction or work incorrectly, or give the user the output that was not expected or desired. So that's why we have this stage of testing and debugging that is meant to help the user to use all the mechanisms available to detect the errors in a program and to remove them. So we usually call that process of detecting and removing errors, we actually call it debugging. So testing, what is testing? Testing is actually the process of learning computer software to detect or find any errors or bugs in the program that might have gone unnoticed. During program testing, the following details should be checked: the reports generated by the system, the files maintained in connection to the system information requirements, the input to the system, the processing tasks, and also the controls incorporated within the system. So when you are testing your program, always ensure that all the following is checked. This will ensure that you'll be able to have all the bugs detected and at the end of the day corrected. Something good to note is that the testing process is a continuous one, and it ends only when the programmer and other personnel involved are satisfied that it is operational and the program will meet the objectives and the growing demands of the organization. So it is not a one thing process or it is not an event. It is actually a process that will be continuous as long as the program is in use. So you find that the persons who are using this program actually are the ones to give you the green light that the program is now operational, and until then you may not be able to say that you have fully developed the program, because it will still require that the users are satisfied that the program is able to meet the objectives of the organization. Types of program errors. Now that we have seen that it's very important to test and debug programs, let's see the types of errors that you are going to come across while you undergo this process. There are 5 main types of errors that can be encountered when testing a program. This includes syntax errors, runtime or execution errors, logical or arithmetic errors, semantic errors, and lexicon errors. We will discuss each and every one of these errors, starting with syntax error. Syntax errors. Every programming language has a well-defined set of rules concerning formal spellings, punctuations, naming of variables, etc. The instructions are accepted only in a specific form and must be obeyed by the programmer. Syntax error, therefore, programming errors or mistakes that occur if the grammatical rules of a particular language are not used correctly. So we are saying that syntax errors therefore will occur when mistakes or grammatical rules are not followed correctly. So this will lead into syntax error. So you have to clearly understand how the programming language that you are using works. You have to understand all the identifiers, all the variables, and how to declare the variables, and always make sure that you are writing in formal spellings, and always make sure that your work is well punctuated. So otherwise, if this is not done, it will lead to what we call syntax errors. So examples of syntax errors, of course, will include punctuation mistakes. If the programmer does not use the right punctuations and spacing needed by the translator program, this will lead into a syntax error. So this may include omitting a comma, or even including one where it is not required, or omitting a semicolon. For instance, in C programming, omitting a semicolon is a very big mistake error, and may lead into the whole program not working. Improper naming of variables. So again, this now will mean that you have not studied your programming language well, and you find that you are not using the variables as they are supposed to be used, or maybe even you are misspelling them. So the other example of a syntax error is long spellings of user-defined and reserved words. So reserved words are those words that have a special meaning to the programming language and should not be used by the programmer for anything else. So always ensure that you use the reserved words for the reserved purposes, and always ensure that they are typed correctly. Logical or arithmetic errors. There are usually bugs in a program that cause it to operate incorrectly. Unlike a program with a syntax error, a program with logical errors is a valid program in the language, though it does not behave as intended. So this is something that is very, very important to understand, that with logical errors, they may not make your program not to operate. Like, your program will still be executed, but what you are going to find is that you'll have incorrect output. So for instance, if you are adding two values, but instead of adding or writing the additional operator, maybe you use the multiplication or the division, so you find that what will result is that the values will be divided or multiplied, but they will not be added as you intended. So in a screenshot here I have a sample program where the user is supposed to find the average of two values. So the user will be required to enter two values and the program will find the average. So we are going to write this in C, and I'm going to make an intentional mistake so that we see how that will work, and I'm going to show you where the problem is to make you better understand the logical errors. So I'll be switching to C, and I had pre-created that, but I'm just going to delete. So this is programming in C. You have to first of all include the header. You have to first of all include the standard input output, and then after that you have to declare that you are starting your program execution at this point. So this should not be curly bracket, should be normal brackets, and then the curly brackets like that. So at this stage now I will declare my variables. So I'll just come and say float average float. So at this point I'm now requesting the user to enter the two values. So I'll first of all request for the first value. So kindly and I also have to add that line by doing that, and also include a semicolon. I'll make the program to read that using the scanf. So these are some of the reserved words in C programming. So if you make a mistake or a spelling mistake when writing them, then your program may not work. Actually it will not work. So ensure that you know them and you type them correctly. So sorry, I have to use punctuation marks here. So again, this should be followed correctly, because otherwise it will make your program not work. We talked about punctuations, so always ensure that you punctuate your work correctly, like where you're supposed to use commas, where you're supposed to use apostrophes. Always ensure that you have them. So just come and read the value A, and then I'll now request for the second value. This should be in quotes, so kindly input the second value and I'll add that line like that. I'll again read that value. Oh, spelling mistake again here. This should be T. So I'll read the value as %f. So the f is representing this float because the result that I may get may have a decimal point. So instead of having it as a normal value where I would have used int or for integer, I've used float just in case the result will be having a decimal point. So this should be in quotes, then comma, then and b. So this is the point where I'll make the mistake intentionally, and then we are going to execute the program and see what will happen, and then we'll collect the error and see what will happen. So this is to just make you understand that some logical errors may go unnoticed, and if the programmer didn't know the expected output, the error may go unnoticed forever. So that's why it is very important for the user to know what is expected, like when the program is run, what should we get. So I'm going to say average. Remember, I had already declared that average on top here. So again, if it is not declared on top here, you're going to have some issues with your code. So I'm actually now telling the program to add the two values that are supplied by the user and divide them by 2, of course, to give me the average. So I'm just going to have it like that, and then I'll print or I'll output. I'll tell the program to output the results. So I'll use again the reserved word printf. So this will actually print or output the results of processing. So it is at this stage that the processing will take place, and at this stage we are like now inputting the values, or what is required, and on top here you are like doing the declaration. So here I'll just come and say the average is, and then again, because it may be having a decimal, I'm going to use the f to represent the float, and then I'll add that line. I also have to have a semicolon there, so if I don't put that semicolon there, it may lead to the whole program not working. Alright, so after that, now what I will do is I will now compile the program. So remember, now what I have here is source code. This will not be understood by the computer yet, so I have to present my source code to a compiler, to a language translator that will translate this source code into object code that will now later be executed, and I'll be given my results. So let me just see what I can do here. So I'll just go on top here and I will compile and run, or let me just compile it first, and I want to show you what is happening below here. So as you can see, I have an error at this point because I used commas instead of semicolon. So these are syntax errors. Actually, these are syntax errors that will be caused by a long punctuation. So that was not a logical error. So let me just save the changes and run it again, compile it again rather. And now you notice that the errors were not noticed. So I have a certain error at this point, whereby I had to include parentheses or brackets, so that now the program first of all adds the two values and then divide them by 2. But the compiler will not notice that error, and it went on to tell me that we don't have any errors. If I go ahead and run that, where now I'll put maybe the values like that, you'll find that the program will give me the wrong information or the wrong output. So it will not be able to find the average of the two values because I have made a logical error. But that was not noticed by the compiler. So that's why it is very important to always go through your program statements line by line, so that you can be able to detect some other errors, some logical errors. Though we have some other mechanisms that you can still use to see whether you have made any logical errors in your program. So let me just collect the error. So it was just required that I have some opening and closing parentheses here. So let me see. Yeah, so I've just collected that. Now I will compile it here. And now you notice that still it tells me that there is no errors, and can now come and compile it, that is run it, and input the same values, and there's still a mistake. Alright, so I forgot to include average here. So that was an omission. So I have to put a comma here and say average. Yeah. So save that. I'll compile it. So no errors. So let me now run the program and see whether it will give me the expected results. And that is quite light. So you can see that you can make some logical mistakes, and this is a very small mistake that may go unnoticed. So you also have to be good in mathematics, especially if you are dealing with some operators or some formulas. You have to always ensure that you write them as they're supposed to be, because with most compilers they will not be able to detect logical errors. So the logical error that was here is that we didn't include the parentheses that should always be there, of course, when you're finding average. The next type of error is runtime or execution errors. These errors occur during program execution. Execution errors occur when the programmer introduces new features in the program which are not part of the translator standards. For example, this may occur if 1. The computer is asked to divide a number by 0. That will result into an execution error. 2. It may also occur due to the number generated as a result of an instruction is too large to fit in a memory location. So remember, when you're declaring your variables, these variables are allocated as memory space. So if the result of a certain process is too large to fit in a memory size, that will result into an execution error. When you raise a number to a very big power that cannot be accommodated in the registers structure of the computer, that will still result into a logical error, execution error. In case of a closed loop in the program, leading to a set of instructions being executed repeatedly for a long time. So you find that there is something that we call looping, where a program will execute a certain instruction until a certain condition is met. So you can set some instructions that will be repeated for a long time, like before the condition is met, there will be a lot of repetitions. So these may at the end of it lead to execution errors. So execution errors are not detected by the translator programs, just like with the logical errors. And sometimes execution errors may lead to premature end of a program. So you might notice that maybe you have a runtime error when you have your program exiting prematurely, like it exits without giving you the desired result. So it might mean that there was an execution error. And to detect and eliminate execution errors, a test run should be performed on the program after it has been translated. So that's why we have this stage of testing and debugging, so that you can be able to eliminate all types of errors using any mechanism available. The other type of error is semantic errors, and these are meaning errors. They occur when the programmer develops statements which are not projecting towards the desired goal. Such statements will create deviations from the desired objectives. Semantic errors are not detected by the computer, and the programmer detects them when the program results are produced. So I have an example here of a program that is required to check the units that are consumed and give a certain output if they are greater or less than a certain value. So as you can see with the statements, is that, for example, with this, I've said that if unit is greater than or equal to 101 and unit is less than or equal to 2000, then the program should go ahead and print the unit that was consumed and also add 10 to it. So you find that if I now make a mistake here and instead of using the adds I use all, this will result into a problem. And that is the end of module 4. See you in the next module. Thanks for watching.